Next, let's take a look at how to calculate and work with maps within the Maestro interface. The process of calculating maps with Primex is really quite simple, and in fact there are a couple of easy ways to do so, either as part of a reciprocal space refinement calculation or as a standalone calculation. To create maps as part of a reciprocal space refinement, we'll head up to the Primex toolbar, click on the Task button, and open up the Reciprocal Space Refinement panel. When setting up a minimization, a rigid body refinement, or a simulated annealing calculation, we can click on the Maps tab and tell Primex to calculate whatever maps we wish to see at the end of the calculation. Then we would run the calculation normally by clicking on the Start button and submitting the job. The settings in this panel are common to those found in a separate standalone interface used to create maps, which we'll take a look at next. To open the standalone Create Map panel, just click on the Create Map button in the Primex toolbar. Most crystallographers will probably find the options here to be very intuitive. At the top of the panel, we check the appropriate toggle to specify what type of map we want to create, a regular map, an omit map, or a composite omit map. And if we choose an omit map, it will allow us to specify the atoms to omit here. If we choose a composite omit map, we can set the percentage of data to omit in this field right here. In this example, we'll choose to create three regular maps, FO, FO-FC, and 2FO-FC. There are some additional options that are fairly self-explanatory, and for now we'll just accept the defaults and create the maps by clicking on the green Start button and submitting the job. At the conclusion of the map creation, the surface table will automatically open up, and one of the three surfaces that we calculated will appear in the workspace. The surface table can be used to determine what maps are displayed and how they look, and we'll return to it in a moment, but for now we'll dismiss it and take a closer look at how the surface appears in the workspace. In order to keep the workspace contents from becoming too cluttered, by default, the map surface is displayed for only a small subset of the protein. Now let's suppose that we'd like to display the map surface in the vicinity of this arbitrary residue that I've just zoomed in on. To do so, we need only right-click on this residue. Doing so will center the residue in the workspace and display the map surface in the vicinity of this residue. Right-clicking on the next residue in the protein backbone will recenter the workspace contents accordingly, and the map that we've calculated is now visible in the vicinity of this newly centered residue. In order to increase or decrease the surface ISO value, we need only click on the appropriately named buttons in the Primex toolbar, like so. Next, let's head over to the project table to see how we can manipulate surfaces there. We'll open the project table by clicking on the Project Table button in the Maestro toolbar. The entry that's currently included in the workspace is marked with an X in this inclusion column here, and we see that the surface column to the right of the entry name is marked with an S, indicating that there are surfaces associated with this entry. Right-clicking on the S button causes a drop-down menu to appear, and the menu is populated with the names of all of the maps that we've created. In this case, the 2FO-FC map is checked, which means that it's currently visible in the workspace. Selecting 2FO-FC from this drop-down menu will uncheck it, and the map will disappear from view. Pretty straightforward. However, using the surface table, it's possible to have an even greater degree of control over how our surfaces appear in the workspace. We can left-click on the S button to open the surface table, or we can head up to the Primex toolbar and click on the Surface Table button. If you're familiar with the project table, the surface table should be relatively easy to master. You can select surfaces by clicking on the rows, and you can display or hide them from view by clicking on the inclusion toggles at left here. But beyond just displaying and hiding maps using the surface table, there are a few additional features available, and they're all very easy to master. To change the color and surface type, for example from blue mesh to a red translucent solid, we click on the Display Options button, and in the panel that appears, we set the style to solid, adjust the translucency to 50%, and change the color scheme to red. We can then click on the OK button to accept these changes. If we want to display more of the surface in the workspace, that's a simple matter as well. Right now, only 10 cubic angstroms in the vicinity of the centered residue are displayed, but it's a trivial matter to increase the volume to, say, 20 cubic angstroms using the Display at Most setting here. And if we want to display the entire surface with no volume restrictions, we can simply uncheck the Display at Most toggle. Notice that there's some additional surface displayed beyond the region of the protein. We can use the limit feature to limit the surface volume to regions that are, say, within no more than 3 angstroms from our protein atoms. To do so, we click on the Limit button, click on the All button to select all atoms in the protein, and then set the distance limit to 3 angstroms. We click on OK to accept the new limit, and any surface that's beyond 3 angstroms from the protein is no longer displayed. Next, let's take a look at how to calculate and work with maps within the Maestro interface. The process of calculating maps with Primex is really quite simple, and in fact there are a couple of easy ways to do so, either as part of a reciprocal space refinement calculation or as a standalone calculation. To create maps as part of a reciprocal space refinement, we'll head up to the Primex toolbar, click on the Task button, and open up the Reciprocal Space Refinement panel. When setting up a minimization, a rigid body refinement, or a simulated annealing calculation, we can click on the Maps tab and tell Primex to calculate whatever maps we wish to see at the end of the calculation. Then we would run the calculation normally by clicking on the Start button and submitting the job. The settings in this panel are common to those found in a separate standalone interface used to create maps, which we'll take a look at next.